Welcome to the deep dive. Today, we're really getting into something foundational, but maybe a bit hidden. Hardware security modules, or HSMs.
That's right.
Sounds super technical, I know, but honestly, these things are kind of the unsung heroes working behind the scenes in our digital lives.
Absolutely.
So our mission today, we're going to unpack this source doc, HSM industry applications and use cases.pdf, and really show you just how widespread and frankly vital these modules are.
And it's crucial to understand why. HSMs are basically purpose-built, hardened devices. Their whole job is protecting crypto keys and, handling really sensitive cryptographic stuff.
Hardened devices?
Yeah, tamper-resistant. It's not just about security features. It's about building trust right into the hardware. That's how they ensure confidentiality, integrity, authenticity, all that good stuff across so many different systems. Think of them as like a super secure vault for digital secrets. Way tougher than just software.
A secure vault. I like that. Okay, let's unpack this then. Where should we start? Maybe with one of the biggest users, financial services.
Definitely. Yeah, the financial sector was an early and remains a massive adopter.
So why? Why are they so critical there?
Well, think about your bank card. HSMs are fundamental to payment card security. They're involved in, generating and storing the keys for EMV chips.
A little chip on the card.
Exactly that. And protecting your PM when you use an ATM, managing the keys for transaction processing, it's all about keeping that whole payment flow secure.
Okay.
And it's not just nice to have. For things like PCI DSS compliance, the standard for protecting cardholder data, HSMs, are often required. Their physical, tamper-resistant nature is key. They're built to fight off attacks, physical or logical, which makes stealing the keys incredibly hard. It basically underpins the integrity of, well, the entire global payment system.
Wow. Okay, so it's not just the card itself. What about the actual money moving around digitally, which is happening constantly?
Right. HSMs handle the encryption and decryption of those financial transactions. So the sensitive data moving between, say, banks, ATMs, payment processors, it's shielded.
Shielded, right.
But it's also about proving the transaction is legitimate. HSMs generate digital signatures. Think of it like a tamper-proof seal.
An unforgeable seal.
Exactly. It ensures integrity, the data wasn't messed with, and authenticity, it really came from where it says it did. This is, absolutely critical for fighting fraud.
I can imagine.
It provides that sort of non-repudiation proof it happened and who did it. And this isn't just for physical cards anymore. It's the same engine securing online banking, mobile payments, protecting keys, handling strong authentication there too.
So basically, every time you tap your card, use Apple Pay, whatever, chances are there's an HSM working away somewhere back there.
Very likely, yes.
Okay, so that's finance. But you mentioned their importance goes way beyond that. How does this shift when we look at, say, governments? Defense organizations? That seems like a whole different ballgame.
It is, and the stakes there are, well, arguably even higher.
Yep.
Governments and defense use HSMs to lock down highly sensitive information. We're talking classified documents, intelligence data, citizens' personal data.
Really sensitive stuff.
Extremely. The HSMs ensure confidentiality, so only authorized people see it, and integrity, so it can't be secretly changed. When a data breach could impact national security, you need the absolute highest level of assurance. HSMs provide that hardware-rooted security.
Okay, what about digital identities? For citizens, government workers, that sort of thing.
Yeah, that brings us to PKI, public key infrastructure.
PKI, right. We hear that a lot.
It's the system behind digital certificates, essentially digital IDs or credentials. HSMs are absolutely crucial here. They protect the most important keys in the whole system. The root keys and the certificate authority, or CA, signing keys.
The master keys.
Pretty much. They're the foundation of trust for all digital certificates issued by that system. If those keys get compromised, the whole trust model just collapses. Everything signed by them becomes worthless or, worse, dangerous.
I see.
That's why you see HSMs approved by bodies like the CNSS for use in national security systems, PKI. It just highlights how critical they are for top-tier security, ensuring those digital identities are trustworthy.
Fascinating. Okay, so from national security, let's pivot to the cutting edge. The Internet of Things, IoT, and blockchain.
Yeah.
These are huge growing areas. How do HSMs fit into these interconnected worlds?
Well, for IoT, HSMs provide what's called a hardware root of trust, right from the start.
Hardware root of trust,
They
meaning
securely create unique identities for each IoT device. Think of billions of devices needing a secure way to prove who they are. HSMs do that. They also enable secure bootstrapping, that's the device's secure first startup, and they sign firmware updates.
So you know the update is legit.
Exactly. It prevents malicious code from being loaded onto the device, and they protect the keys used for secure communication between the device and, say, the cloud.
Yeah.
So from the moment an IoT device turns on, its basic identity and software integrity are protected.
Okay, that makes sense for all those smart things. Now, what about blockchain? Cryptocurrencies, decentralized systems. Trust is kind of spread out there, isn't it?
It is, and HSMs add a critical layer of security there too. They protect the private keys used to digitally sign blockchain transactions.
Which is vital for proving ownership and preventing fraud.
Precisely. Things like double spending. They also help secure the consensus mechanisms the processes networks use to agree on transaction validity. For crypto exchanges or any serious blockchain application, protecting those keys is paramount.
So the HSM is like a personal vault for your blockchain keys?
In a way, yes. It provides that physically secure environment, making it incredibly difficult for attackers to steal or tamper with the keys needed to control assets or manipulate the ledger. That's vital for trust in a decentralized world.
Okay, so it keeps coming back to this idea of digital identities and secure signing, doesn't it?
It really does.
Which brings us back around to PKI. You said HSMs are crucial there. Can you elaborate on that fundamental link and what does it actually, enable for us day to day?
Yeah, the link is foundational. HSMs are the trusted root in almost any serious PKI setup. They generate, store, and manage the use of those critical root and CA signing keys we talked about.
The guardians of the keys.
Exactly. Their security underpins the trustworthiness of every single digital certificate issued by that PKI. If you trust the HSM protecting the root, you can trust the certificates for websites, for identities, for code. Without that hardware security, the whole system is shaky.
So what does that mean for, me browsing the web or getting software? What am I seeing that relies on this?
Well, quite a lot, actually, often without you realizing it. Think about code signing. That little pop-up saying software is from a verified publisher. That relies on keys likely protected by an HSM, ensuring the software is authentic and hasn't been infected with malware.
Okay.
Then there's document signing. Signing contracts or official documents online securely. HSMs often protect the keys that make those signatures legally binding. And of course, website security, the padlock in your browser.
HTTPS, right? SSL/TLS.
Right. HSMs secure the keys for those certificates. And there's a performance angle, too. Those cryptographic operations, especially things like RSA, which are used in TLS, are computationally heavy.
They slow things down.
They can. So HSMs can take on that workload, offloading it from the main server CPU. This speeds up the process of establishing secure connections so you get faster, more responsive, skisher websites, secure communications.
Faster and secure. That's a good combo. Okay, one last area. We talked finance, government, IoT, PKI.
Yeah.
What about just general enterprise IT? How are businesses using HSMs more broadly?
Yeah, definitely. In a typical enterprise environment, you'll see HSMs used for several core things. Database encryption is a big one, protecting sensitive customer or company data stored in databases.
So data at rest.
Exactly. Also, application-level encryption, maybe encrypting specific fields within an application. We mentioned TLS-SSL acceleration for web servers already. And another key one is privileged access management, or PAM.
Securing the keys to the kingdom, basically.
Kind of, yeah. Securing the credentials that administrators use to access critical systems. The benefits for businesses are pretty clear. Strong data protection, whether it's stored or moving, better system performance from CPU offload, easier and more secure key management because it's centralized, and, importantly, meeting compliance requirements. Lots of regulations demand this level of key protection.
Right, compliance is huge. So it really is amazing just how pervasive these devices are. There's sort of this invisible security layer beneath so much of what we do digitally.
That's a good way to put it. Invisible, but essential.
So what does this all mean for you listening right now? Well, from tapping your credit card to your government verifying your identity online, even the smart thermostat in your home. HSMs are very likely working silently in the background, ensuring those interactions are secure and trustworthy. They really are this unseen bedrock of trust in our digital world.
It really makes you think, though, doesn't it? As our lives get even more digital, more connected, with AI, quantum computing on the horizon, how does this fundamental role of hardware security modules need to evolve? What are the next big challenges? What new demands will be placed on these critical vaults in the future? That's the really interesting question going forward.